Good evening, sir. Yes, sir. Thank you. A very good evening, everyone.
Good evening, ma'am.
Good evening, sir. So I think we can start the session now, right? Shall I?
Yes, ma'am. Yes.
Yes. So at the onset, I'll say yesterday we discussed about the non-parametric test, which is the chi-square test, right? Today, or I can say from today onwards, we will see the parametric test, and I'll talk about the t-test, right? Before proceeding and starting and talking about the t-test, may I know how many of you are having that what t-test is, for what purpose we are using the t-test, and what is t-test is all about? Anyone? Yes. Anyone? No idea? Okay, so I don't know what I need to understand from this silence, whether you people are knowing or not knowing.
Please tell us, ma'am.
Okay, fine, sir. Thank you. Fine. So I think I'll start with today's test, that is the one sample t-test, and I'll first try to build the conceptual aspect of one sample t-test, and then we will see how using the SPSS we can apply the one sample t-test, right? So give me a second. I'm going to share my screen first with all of you. Okay. I think I shared the sheet with all of you. I hope it is visible.
Yes, ma'am.
Yes. So, firstly, before talking about the one sample t-test, firstly, we'll see what is t-test, right? So, and before talking about the t-test, I think I need to tell you what is the parametric test, because t-test comes under the parametric test category, right? So yesterday when I talked about the non-parametric test, I told that when we are talking about, or when we are having the categorical variables and we are not bothering about the normal distribution of the variables, in such case we need to apply the non-parametric test. So other way around, when I talk about for the parametric test category, or in contrast, I must say, when I talk about the parametric test, we can say parametric tests are based on the parameters of the population. And also we can say in such case, we need to generally check the normality of our variable, right? So parametric tests are, again I'm repeating, based on the normal distribution. And also these tests are considering the population parameters. So those who have applied t-test manually, probably they are knowing what the formula of t-test. Generally, the formula is based on the mean, right, and the standard deviation. So parameters are what? Parameters are nothing but these are the features or qualities or characteristics of the population, right? So when we talk about the characteristics of the population, so we can describe the characteristics in terms of mean, proportion, variance, etc. So again, I'm saying when I say the parametric test, that is the t-test, So in that case, the formula, if you have seen the formula, you are knowing this thing. In the formula, there is the mean and the standard deviation, right? Whereas when we have seen yesterday the chi-square test, in that case, we have seen the formula was not at all talking about or not at all considering these parameters, but whereas the chi-square formula is considering the frequencies or count, right? So because these are the characteristics and these can be expressed in the continuous form or numeric form, right? That is why parametric tests are considering the population parameters like mean, variance, proportions, etc. And also these type of tests are considering the normal distribution of the data. In this particular category or group or family, we can say there are so many tests available like t-test, z-test, ANOVA, then correlation, regression. So these are some of the tests name which I have told you. Now, today, when we talk about the one sample t-test, now I will firstly talk about the t-test. T-test is again a kind of parametric test, right? So t-test is the parametric test, meaning is that it is also considering the continuous variables. It is also considering the mean, standard deviation, etc. And also it is considering the normal distribution of the data. Second thing is, what is the purpose of t-test? So the purpose of t-test is to find the significant mean difference. So whenever we are interested to see the mean difference, we are talking about the t-test, right? Now, the varieties in the t-test means what are the various types of t-tests available. So there is one sample t-test and the two samples t-test. Today, I'm talking about the first case, which is the one sample t-test, right? So now I'm coming to the today's topic, which is one sample t-test. So one sample t-test, as it is a t-test, it is a kind of parametric test, right? So this test helps us to determine whether the sample mean is statistically different from the known or hypothesized population mean. Right. So I think before talking on this particular point, I will say when we talk about the hypothesis, right? What is hypothesis generally? Hypothesis is generally known as an assumption, right? Or you can say it's a tentative conclusion. Generally, if you have formulated your hypothesis or you have read certain research papers, you have seen the papers or you have seen the hypothesis available in the papers. Generally, these are nothing but these are the conclusion kind of statements, but these will be tentative in nature because using your data, whether the data is supporting your hypothesis or not, so we are accepting or rejecting the hypothesis. So if you are accepting, that means whatever is the tentative assumption you have taken, that will be the true for you, right? Because it is supported by the data. So generally there are two variables we are considering for formulating the hypothesis. But when we talk about the one sample t-test, in case of one sample t-test, when we are considering only one sample, right? So that means how we will formulate the hypothesis. So in such case, we are comparing the sample mean, whatever sample we are considering. That sample mean we will compare with the population mean or the hypothesized population mean. Means the population mean should be known to you. If it is not known, you need to take certain assumption of that population mean. So that way you will compare the population mean and the sample mean in case of one sample t-test. So the variable which we are using to test in the one sample t-test is known as the test variable. So test variable is compared against the test value. Test value means the hypothesized value of your population. So you need to compare these two, and that way you will say whether the sample is coming from the same population or not. So that means one sample t-test will try to declare this thing that whether the sample is belonging to the population from what means whatever that test value, that is the population hypothesized population mean value you are providing. So that way it will compare, that means, and if there is no significant difference, that means you will declare this thing that there is no difference, that means the sample is belonging to the population which you are talking about, or whatever population you have given the value to the software, right? So now the next thing is, I think most of the people are talking when the sample size is less than 30. In such case, we are using the t-test. Apart from this condition of less than 30, there is one more condition, and that condition is very important. And the condition is that the population standard deviation, or you can say population variance, is unknown. So this is the difference in z-test and t-test. Apart from the large sample and small sample, the major difference in the z and t-test is the standard deviation or the variance of the population should be known or unknown. Unknown meaning you will use the t-test, and known meaning you will use the z-test, right? So this is the basic difference between the between the t-test and the z-test. Now, talking about
Ma'am, one second. Ma'am, just make it clear again. If the sample size is 30, less than 30, then we make use of t-test or z-test.
usually, according to the books, ma'am, because I think being a student, I think though if you are academician and if you've seen the books of statistics, means suppose it is not necessary you're belonging to the statistical field. If you have seen the books of research methodology or the statistics, generally it is a notion when the sample size is less than 30, we are using the t-test. When sample size is greater than 30, we are using the z-test, right?
Okay.
Apart from that, the main difference in these two is that the t-test is we are using when the population variance or the population standard deviation is unknown. Means you are not much clear about the complete population, right? And when you are having the complete idea about your population, that means you are having that standard deviation or variance of that population. So that way you are using the z-test. Is it clear, ma'am?
Yes, ma'am. Yes, ma'am. Very clear.
Yeah. Give me a second. Yeah. So I hope it is clear to everyone.
Yes, ma'am.
Okay. Give me a second. I need to see something. Okay, fine. So if it is clear, then it's good. I'll move now to the next slide. Now, procedure of applying the t-test, one sample t-test manually. So I think hypothesis testing procedure is known to every researcher, I think, and academician also. So you can see this in a quick way that firstly we need to define or write our null and alternative hypothesis, right? Then we are setting the alpha value. Alpha value is what? It is the level of significance, right? So you need to ascertain whether you want to take alpha value as 5%, 10%, or 1%. So these are the various percentages available that you can consider. Apart from that also, if you want to set some other alpha value, that also you can use. But mostly used are the 5%, 1%, and the 10%, right? And most of the softwares are generally by default considering 5%. But it is like means whatever software you are using, it is like you can change also. It is not mandatory because software is generally using by default 5%. But if you want to make changes according to your assumption, that you can change. Next one is you need to calculate the degrees of freedom, right? So after calculating the degrees of freedom, you need to state the decision rule. So in case of t-test, generally, I think I have said this thing in case of chi-square. I have shown the table. I think in the upcoming slides, I'll show you the table of t-test also. So in case of t-test, if you want to get the table value or the critical value, so you need to have two things. Again, same, that is the degrees of freedom and the level of significance. So if you are having these two values, you can get the critical value from the table. And then you need to declare the decision rule. So I think we have discussed the decision rule yesterday. I said when we are talking about the p value, so the decision rule based on the p value will be if your p value is less than level of significance, in that case you are going to reject the null hypothesis. But if your p-value is greater than the level of significance, in that case, you need to accept your stated null hypothesis. After that, you need to calculate the test statistic. So here we are talking about the t-test statistic. So the formula is quite visible, I hope, to everyone. That is t is equals to x bar minus mu 0 divided by s divided by root n, right? And then till here, I think I'm clear to everyone.
Yes, ma'am.
Fine. So further, we will see the table. Now you can find this is the table here. This table is at the extreme left, the first column you can see, which is for the degrees of freedom. So according to the sample size, you can calculate the degrees of freedom. And according to whatever level of significance, that is generally level of significance is the kind of risk, right? Generally, it is known as type 1 error, or it is a kind of error we are assuming, right? So according to that percent, you can locate the percent here, whether your test is for the one tail or for the two tail. That way you can decide upon. And according to the degrees of freedom, intersection of these two will give you the value of table value of the t, or the critical value of the t, right? Further, I'll talk about the hypothesis formulation of the one sample t-test. Here you can find null hypothesis for the one sample t-test is mu is equals to x bar, because as I said, we are comparing the population mean from sample mean from the population mean. So mu is your population mean, x bar is the sample mean. This is the symbolical way of presenting the null hypothesis, right? So here we are saying mu is equals to x bar. Alternatively, we are saying mu is not equals to x bar. Meaning is that number of tails, when I talk about this, are 2. Question comes, what is this tails, right? I think you people are already knowing that normal distribution is generally shown by the bell-shaped curve. And in the bell-shaped curve, there are 2 tails, left tail and right tail, right? So when you are talking about the first case, when you are saying that your alternative hypothesis, that is mu is not equals to x bar. So meaning is quite clear. We are saying that population mean is not equals to the sample mean. That means it can be either greater than or it can be either less than. But we are not declaring anything clearly. Only we are saying that these two means are not same. That means in that case, both the tails will be involved. Means this way, the rejection reason will be falling on the both the tails of the normal distribution curve. So here you can find this. Here you can see, here if I talk about this, you can see that when we are talking about the two tail test, here in that case, these red color of the red color on this particular curve is showing. This is the rejection reason of your null hypothesis. So you can say this is a kind of first way of formulation of the null hypothesis and alternative hypothesis for the two tail test. Now for the one tail test, remaining two situations are mentioned. That means null hypothesis will be saying mu is greater than or equals to x bar, and alternatively we are saying mu is less than x bar, or vice versa, mu is less than or equals to x bar, and alternatively we are saying mu is greater than x bar. So looking at your alternative hypothesis, you can comment now. Both are clearly stating whether the mu is greater than or less than from the sample mean, right? So this means it is a clear indication that the rejection reason will fall on the either of the tail. So when we talk about the second case, which is mu is less than x bar, that means this is the left, what I can say, left tail test, right? So left tail test meaning your rejection reason will fall on the left tail, right? So one tail is involved here only. In case of the third situation, the rejection reason will fall on the right tail, which is mu is greater than x bar. So it is again a case of one-tailed test. Is it clear?
Ma'am, x bar is a single value, na? That is the sample mean, and mu is the population mean.
Yes.
So
Ma'am, in this
suppose
diagram, where will be the position of X bar?
Ma'am, usually the X bar, as I said yesterday, I think yesterday or day before yesterday, when I talked about the normality, the middle line is indicating the mean value. But it is the population mean, because normal distribution curve is only for the population mean. Generally, it is we are showing this is the standard curve, because right. So the middle line will be the mean line. If you will draw a line from this particular point, so this will become your mean.
Okay, ma'am. Thank you.
Yeah. Yes, Sanjay ma'am, I think you were saying something.
No, ma'am, same question. For this, the level of significance is 5%. And
This is
this,
by
I,
default, because this is the image I have taken
hmm,
from the net. But it is like for any person, always the according to your left and right tail, the rejection region will fall according to at the left tail or the right tail. Person can vary.
hmm. Yes, ma'am.
Getting?
Yeah, yeah.
Fine. So may I proceed?
Yes, ma'am.
Just a minute, I think this. Now, I think previously you have seen these are the three hypotheses which are in the symbol form. But if you want to write your hypothesis in a word form, so that also we can do, right? So in a word form or in a statement form, you can write your hypothesis like there is no significant difference in the sample mean and the population mean. So this is a one hypothesis. So alternatively, if you are saying there is a significant difference in the sample mean and population mean, that means that will be the two-tailed hypothesis. Two-tailed meaning because you are saying there is a significant difference, but you are not ascertaining whether the difference is greater than or less than. So that way it will be a two-tailed test. Whereas when you are saying sample mean is significantly less than or equal to the population mean, or sample mean is significantly more than or equal to the population mean, so that means their alternative hypothesis will be very clear. Here in the this second case, you will say sample mean is significantly greater than to the population mean, or you are saying sample mean is significantly less than to the population mean. So the direction will be very clear whether it is greater than, less than, something like that, means that is a case of one tail. But whereas the direction is not clear, you are saying there is a difference. So direction can be at any side. So that is a case of two-tailed test. Is it clear? I hope. Yes.
So basically what you're saying is in case the hypothesis is open, then it's a two-tailed test. If the hypothesis is towards on one side, then it's a one-tailed test, right?
Yes. Yes. Fine. May I proceed?
Yes, yes.
Yes, please.
Yes. Now, the most important part is the assumptions. So you need to talk in, as I think yesterday also when we have seen the chi-square test, we have seen the assumption of chi-square test. There was hardly a one assumption or two assumptions which we have seen. In case of one sample t-test, we will see the assumptions and we'll see. So that way you can see that what are the assumptions of one sample t-test. So first assumption says the dependent variable must be continuous. That is, it should be measured on interval scale or ratio scale. Although in case of one sample t-test, we will be having only single variable because it is the kind of one sample t-test, right? So we will be having only one variable, one sample we will be having of it, and that will be the dependent variable, means that variable will be treated as dependent variable, and it is known as continuous, or you can say it should be a variable on the scale of interval or on ratio scale, right? Second assumption says the observations are independent of one another. So when you are collecting a data from one person only once, that way this particular assumption can be maintained by you, right? That means if suppose you are having 30 people, so for every people you are collecting data of whatever characteristics only once. That way this assumption can be maintained. But for suppose you want to increase the sample size or something and we are making it double, that means this assumption will be violated, right? Next says the dependent variable should be approximately normally distributed. So your continuous variable should be normally distributed. That you can check. I think you can recall the previous session where we have seen how we can check the normality. So using the graphical methods or the numerical methods, we can check the normality of the variable. Next one is the dependent variable should not contain any outliers. There should not be any outlier in your dependent variable. Outlier meaning is what? These are the extreme values. So these extreme values can be either side, either it can be the upper side or either it can be the lower side. So in that case, you need to see there should not be any outlier or significant outlier available in the data. So using the box plot that you can check. Now I think if suppose you are using the histogram method for checking the normality of your variable, and if suppose this kind of histogram means, although it is not necessary same type of histogram you will get, there can be any shape you are getting of the histogram. But suppose this type of histogram is coming, so somewhere you can call it as, if this type of distribution is showing that your variable is approximately normally distributed, right? Now, talking about the outliers, you can see the outlier here. So the upper and the lower whiskers. So I think you are knowing these terms. I discussed in the normality session that when we talk about a box plot, in a box plot there are generally 5 things. The middle line is indicating the median. Upper line of the box is indicating the third quartile. Lower line of the box is indicating the first quartile, and beyond the third quartile is beyond this upper line, whatever area is coming, this is known as upper whisker, and this area is known as the lower whisker. And if your data points are falling beyond these whiskers, maybe at the upper side or at the lower side, in that case these are known as the outlier, right? So distribution of data can be anything. So here you can find here the data range is very small. It is from around some -1 or -2 to approximate 3 something, right? Here the data range is very like from -2.5 something to 2.5, -2.5 to +2.5. So beyond these whiskers, if the circles or the asterisks are coming, generally this is indication of the outlier in your data, right? Is it clear?
हाँ मैम
Fine.
clear.
Now, I think this is also I have explained you when we were talking about that the normality session. So if you are getting box plot like this, generally it is known as a symmetrical distribution. That means your data is not skewed data. So here you can say your data is normally distributed. So this is the distribution. This is using the histogram, and second one is using the QQ plot, right? Coming to the right side, upper side, you can find this is indication, because if you will put the bell-shaped curve on this, so that will be the positively, because the right tail will be longer than the left tail, right? So it is known as the positively skewed data. And in case of QQ plot, if this type of curve is coming above the line, that means it is a positively skewed data. Then again, you can come down lower side, left side I'm talking about. This is again the symmetric data, but here the tails will be flat. Fat meaning is there are so many small. You can find so many small bars are coming. So these are indication that there are so many data falling on the tails. So in such case, the graph, if you are showing the data through the QQ plot, so in such case your graph or the QQ plot will be like this. In case of negatively skewed data, you can see here your left tail will be longer than the right tail, and the QQ plot curve will be like this, right? So it will be coming to the downward side, and it will be, in case of positive skewed, it is coming at the upper side something. So that way you can comment on the normality using the histogram and using the QQ plot. Then further, how to apply one sample t-test. This is the procedure I think that we will see in the case of SPSS, right? So this is about the conceptual aspect of the one sample t-test. I hope it is clear to everyone.
Yes, clear.
Fine. So I have shared the sheet which we need to use today in the WhatsApp group. I hope people have received the same.
Yes, ma'am.
Fine. So if you have received, I am expecting you. Please open it. Give me a second. I'm sharing again. Yeah. Visible, I hope, right? Everyone has opened the sheet. Shall I start and making you clear this thing?
Please.
Any confirmation? Shall I start?
Yes, please, ma'am.
Yeah, fine. Thank you so much, sir. So friends, you can see in this sheet, we are having certain variables available named as ID, score, IQ, and weight, right? You can come in the variable view, you can check these things. Score, IQ, weight, all three are, we have taken as a scale variable, and we know, I think these all are the numeric variable and can be set as a measurement scale of these variable can be set as a scale, right? Now, here, as I said, when we talk about the one sample t-test, in that case, you need to have only one variable that I already told you. First assumption was saying that variable should be continuous in nature, right? So as I think we have seen, all the variables are in the form of number, and we know, or anyway, these variable can be in the decimal points also. So all these variables are numeric, or you can say are the continuous variables, right? So first assumption you have maintained. Second assumption was talking about the observations should be independent. So we can assume this thing because I think I have provided you this data. So I'm saying this thing that all the data points which are mentioned here are taken from the individual ones only, right? So from one individual, only the one time that score data, IQ and weight data was collected, right? So that way, second assumption is also checked by us, and we have seen all both the first two assumptions are satisfied. Now we will talk about the next assumptions, that is the normality and the outlier, right? So I hope till here I am clear.
Ma'am, continuous doesn't mean 0 to 10, 10 to 20, 20 to 30.
That is the range, if you are saying, no ma'am. So that is the continuous series, but I think when
Uh,
you're saying 0 to 5, so that means in that range value can be anything. It can be 0.2 also, it can be 5,
hmm,
4.3 also, anything. 0 to 5.
hmm,
It is
hmm,
interval, right? In that range,
hmm.
any value can be accepted by the variable.
Okay. So this is also a continuous value. I mean, any score can be there from 0 to 100.
4 can be in the decimal point also. IQ,
Hmm.
all the three variables can be decimal point. Possibility is there.
Yeah, so they are continuous. Yeah.
We don't need to see the values, we need to see the nature of the variable. That these variables
Hmm.
can be expressed in the decimal points.
Yeah, correct. Got it.
Yeah. So if it is clear to everyone, and now we will proceed. So I am only taking the first variable, and rest two I think you can do by your own as a practice. So I'm just telling you for the IQ, and then we will wait after the discussion. I'll give you few seconds for performing the test on the remaining two variables, right? So now I talk about the IQ score, right? So I think this is very much known to every one of us that when we talk about IQ, IQ means intelligence quotient, right? And we know for a sound body and sound mind, the IQ value should be 100, right? So this is not given by me or any particular person, but I think this is what I can say kind of thing is known to every one of us, and science has said if a person is sound minded, so in that case the IQ value will be the 100 minimum, right? So that way we can say this thing that the hypothesized value will be 100 of the population, if I say, right? But before performing the one sample t-test, we need to firstly check the remaining two assumptions, right? So we will proceed to the analyze, go to the descriptive statistics, and we'll go to the explore. So I hope every one of you, those who are performing, has located it. Those who are not performing, they have noted down. Done? Yeah.
Yes, madam.
Fine. Click on the explore. Now shifting the IQ variable in the dependent list box. Done.
Yes, ma'am.
After that, we will go to the plots. Here, box plot, whatever is, we will go with the by default. Stem and leaf ID selected the histogram, and selected the normality plots with tests. Then
We will deselect stem and leaf.
yeah, it is older method. So why to go in that? We'll go in the histogram.
Okay.
Okay, so shall I press continue?
Yes, please.
Yeah. Okay. I think rest of the people are also performing or maybe noting down these steps. So now I think we are all set to get the output. You need to only click on the OK button. So may I?
Yes, ma'am.
Yes. Click on OK to get the output. Fine.
Ma'am, please repeat these steps again.
Okay. Go to the analyze, descriptive statistics, and explore. Fine.
Okay, ma'am. Okay, ma'am.
Then once you will click on this, you need to shift your IQ variable in the dependent list box. Done.
Done, ma'am.
After that, you will go in a plots. You select stem and leaf and select histogram and select normality plots with S. Done.
Done, ma'am. Done.
Press continue and press OK.
Okay, ma'am.
Done.
Ma'am. Done.
Okay. So shall I proceed?
Yes, ma'am.
Okay. Just a minute. Fine. So now I'll explain you the output, I think, which I already discussed previously. So here you can find case processing summary. IQ is the variable. For that we have applied this. Total observations are 40. No missing values, so total is 40. Coming to the descriptive statistics, the mean is 109.45 of the IQ. 95% confidence interval of mean is 107.73. 5% trimmed mean means after removing of the outliers, 5% from both the sides, the remaining observations mean will be 109.42. Median is 110, means 50% of the people are having IQ value less than 110 and 50% people are having the IQ value greater than 110, right? Variance of IQ is 28.81. Standard deviation is 5.36. Minimum of the IQ is 99. Maximum of the IQ value is 121. Range is the difference of these two, which is 22. The interquartile range is 9. Skewness is minus 0.38 and the kurtosis is minus 4.88, right? So looking at these two values, because when I talk about the normal distribution using the skewness and kurtosis, you can find the skewness is negative, but it is very small figure. But if suppose if you want to comment, so maybe you can say it is almost equals to 0. Similarly, kurtosis also you can say it is almost equals to 0. So somewhere you can say this thing that your IQ variable is normally distributed. This is what you can comment on the normal distribution of the IQ variable. Apart from that, there is one more, what I can say, characteristics of the normal distribution. Generally, for the normal distribution, if you can recall, I have shown you 3 graphs. In the middle graph, I told you mean, median, and mode are equal, right? In case of the normal distribution. So if I will see the mean value of the IQ and the median value of the IQ, you can find there is a very small difference in these two figures. Only 0.55 is the difference, right? So somewhere you can say that IQ is approximately normally distributed. So we'll proceed further and we'll what I can say, ascertain the normality of IQ with the help of Shapiro-Wilks test also. So at the next table, test of normality, you can find for the Shapiro-Wilks test, the significant value is coming as 0.684. 0.684 meaning is what? It is greater than 0.05. So if it is greater than 0.05, in that case, you need to hold the null hypothesis of Shapiro-Wilks test. So I think you are knowing, I told you for this test, the null hypothesis is the variable is normally distributed, right? So you can say IQ is normally distributed as the P is greater than 0.05 for the Shapiro-Wilks test. Then going down, looking at the histogram, although the histogram is not coming properly, so the reason is because we are having the very less number of observations. We will double click on this. I'll use this ribbon, and from this, the second last, that is show distribution curve, I'll use, and I need to only close this, and I can close this. So somewhere you can say that this distribution is indicating it is approximately normally distributed variable, right? QQ plot is saying if you will say the if you will see the fitted line, data points or the observations which you are having, they are almost following this line, right? There is very less deviation from the line. So somewhere you can again comment that the normality is approximately normally distributed if you are confirming this using the QQ plot. This you do not need to report or interpret directly. You can come to the last plot, which is the box plot. Looking at the box plot, you can see either side, means either you will go the upper whisker side or will come to the lower whisker side. Above these, you are not getting any circle or asterisk. That means there is no outlier available in the IQ variable. So remaining two assumptions we have checked. Is it fine?
Yes, ma'am.
So, shall I proceed?
Ma'am, in my SPSS, the Shapiro test is not seen. I am able to see descriptives after that straight away the histograms.
I think you have not selected that the normality plots with tests. You need to select that, sir.
Which one, ma'am? Normality?
Plots with tests. Tests
Okay.
that you need to select when you will go in the plots button.
Okay, ma'am.
Done. So I think we are done with all the assumptions checking. All the assumptions are met by the data. Now we are set to perform one sample t-test. So shall I?
Yes, ma'am.
Fine. For performing one sample t-test, we need to go to the analyze. We'll go to the analyze. We'll select the compare means, and from here you need to select the one sample t-test. I hope you people have located. I am waiting for your confirmation. Yes. I hope you people have found.
Yes, ma'am.
Analyze, compare means, and one sample test, right?
Yeah.
Yeah.
Shall I?
Yes, please.
Okay. Now you can click on this. The dialog box will appearing for you.
Yes.
Just a minute. There is an important message for the student. Give me a second. I'm just sharing to them. Yes. Fine. Now you need to shift your variable which you want to test. The test variable is the IQ, which you are shifting in the left box. Done.
Yes.
Now the test value means the hypothesized population mean value or the population mean you need to pass here. So as I said, we are talking about IQ variable, and we know generally the average IQ is 100, right? So you need to enter here 100, right? So again, means before proceeding, I must say here that when we talk about the one sample t-test, we need to have the idea about the population mean, or you need to take certain assumption about the population mean. A hypothesized mean is the assumed mean of the population. Fine.
Meaning the whatever is the, like you have taken in case of IQ, it is known 100. Let us say I take the example of yesterday, number of business owners. Suppose the data is available from a government index. So I put that number, or what do I do?
If it is available, it is well and good, sir. But it is when I talk about IQ 100, although it is given in reports also. Generally, average IQ is 100 because we know for a sound mind, IQ should be minimum 100. And I think we know in the real world, there are people who are sound minded. There are very less people. Those who are having the problem with these kind of having the problem of the mind related things, right? So somewhere we can say the average IQ is 100, right? Similarly, as you said, if the reports are giving you the average value, because mean, this is the mean values. Test value means it's a mean value, right? Mean of the population. So if the reports are saying on an average the mean of so and so thing is this, so you can consider that also by giving the reference in your research from this particular research or from this particular report, you have taken this average value.
But ma'am, if we don't have any base for this test value, then what should be the logic for the by default test value?
I said you need to assume and you need to have at least whatever sample you are using for this. Say, for example, suppose I'm talking about MBA because I teach in MBA classes, right? So suppose I have conducted a test, right? I'm having their scores, but with my experience, I know what is the approximate average for this particular subject in the MBA. So accordingly, I can assume it will be around 50, 60, something like that. So that way you need to have certain, means you will be having that idea or not. You can discuss with the people, or maybe you can refer the government reports or whatever variable you are treating in this particular, in that particular field. You can find the reports and get an idea.
And if we take the approximate near about value of our calculated mean, then
So in that case, the t value will be almost 0, ma'am.
okay. Okay.
Because it is your, as that is why I have just a minute, that is why I have shown you the formula also. Formula is saying what? X bar minus mu, population mean minus sample mean. So that way it will be 0, very close to 0. So in
Yes,
that
ma'am.
case, anyhow your null hypothesis will be accepted. Without a doubt, you can say this thing. Without performing even, you can say your null hypothesis will be accepted.
Okay, ma'am, got it.
Right?
We can also take the sample size number as the value. Is possible?
Sorry, repeat again, sir.
I'm saying for the test value, we can take the sample size number also as the test value. The
Number
question is
on an average, depending, sir. See, as I said, I'm measuring the IQ, right? So IQ is not having any unit, although, right? It is only a number only, right? IQ is, I'm saying, a kind of index kind of thing, right? It's 100. So that way, if you're, as I think from your example, I'm generally guessing this thing because you said business owners. So in reports, you will get number of businesses. So you're comparing two things here, both the variable in units will be same. The population mean and the sample mean, because you are only talking about a one variable. So the unit will be same if that is an index form, that is a number form. So the population value will also be in the number form. What is the problem?
okay.
Okay, any other doubt, or shall I proceed? Yes.
Please proceed, ma'am.
Yeah. After that, nothing you need to do. Still, you can see and go in the options button. It is indicating confidence interval percentage 95. That means level of significance by default is 5%. If you want to make any changes using your keyboard, you can make the changes here, right? Fine, everyone. Or else, if everything is fine for you, you can press on continue. And once you will hit the OK button, you will get the output. So I think I am all set. May I?
Yes, please.
Yeah. So once I'll click on the OK button, I think everyone is getting the output like mine. So I'll start explaining you the interpretation part here. So the first table is saying your variable was IQ, total observations was 40, mean IQ was 109.25, and the standard deviation in the IQ value is 5.368. Standard error of mean is coming as 0.849. Coming down, talking about the table or the output of the one sample t-test, you can find it is 11.133 is the t value, right? And the degrees of freedom, it is n minus 1, 40 minus 1, which is 39. Significant value is coming as 0.000. So I think as per the thumb rule, we know this significant value means this is the p value. So this value is less than 0.05. In that case, you are going to, anyone?
Reject
We are, yes, we are rejecting or we are not accepting the null hypothesis.
the null hypothesis.
Yes, very correct. So that way we are not, what I can say, accepting the null hypothesis, and that way we will conclude there is a significant difference in the population mean and the sample mean. Is it clear?
Yes, ma'am.
Right. Now, usually when we talk about this, what I can say, two-tailed test, right? Because the hypothesis is for the two-tailed test, because I have concluded my what I can say result as there is a significant difference in the population mean and in the sample mean, right? So now looking at the results, we can say because the difference is significant, right? So you can see the difference is coming as 9.450, and we are knowing the sample mean was 109.45, and we have passed the population mean as 100. So we can say sample mean is greater than population mean, right? Getting me?
Yes, ma'am.
Yes, ma'am. T value
Yes, ma'am.
is, ma'am, from where you got greater than 100, test value is 100 and the sample mean is 109. Okay, so sample mean is greater than test value. Yeah,
The population mean.
population mean.
One more thing, you can see there is one more section named as 95% confidence interval of the difference. So in this case, lower and upper limit or lower and upper values is given. Means this is a kind of range given to us. So the important thing is that you need to see these two values should be either positive or negative. Means it is generally if these two values are positive or negative, means it is like one should be positive and one should be negative, or vice versa. That will not work. Both should be either positive or negative, so that way you can say the results are reliable. Generally in some of the journals, or maybe some of the times, people are asking what is the 95% confidence interval of the mean or the difference. So in that case, these people are generally looking whether these two ranges are positive or negative. So that we need to see these should be either positive or negative. There should be what I can say, there should be no contrast. One is positive, one is negative. That should not be there. Fine.
Okay.
Now I'll come back to the sheet, and now you need to perform and interpret the thing. Now question comes, suppose we are having the score data available here. Out of 100 scores are given, right? So suppose this is the score I have taken from a subject which is very easier for the student. Suppose it's business communication, right? So now I need to see, because these are the sample, or I can say these are the mean I collected from the students, right? So I need to have idea that in generally in business communication, what is the average score coming, right? So say for example, it is 65. So now the task is for you, assuming the test value, that is the population mean value is 65. You need to comment on whether the sample mean is greater than or less than from the sample population mean, right? I hope you are getting me.
Yes, yes. I'm performing. Yeah.
Yeah, thank you, ma'am. What about the rest of the people? I think almost 32, 33 people are there in a meeting. I hope people are listening, or maybe making the notes, or maybe performing along with me.
Yeah, ma'am, I have done. I've got the result.
Okay.
So,
Yes.
what was the question you had, ma'am? Sorry.
Okay. I said assuming the test value is 65, you need to comment whether the sample mean is greater than or less than to the population mean or the test value.
Okay, give me 1 second, ma'am.
Okay.
So sample mean is greater than the test value. It is 68.53.
Yeah.
Sorry, repeat, Sanjana ma'am.
Uh, Sample mean is greater than the test value.
Okay,
The value of sample mean is 68.53.
68.53. Okay, fine. Means the difference is significant or not? You need to firstly comment on that. P
Not
value.
much. 3 points,
What is the
ma'am.
P value?
P value is 0.186.
No, P is 0.186.
More than 0.05.
You need to accept your null hypothesis. No.
Except your null hypothesis.
Yes. If you are accepting the null hypothesis, that means you cannot compare the populational sample mean in that case, because you are saying there is no significant difference. Getting me?
Since it is 0.05, so
You need to firstly
not,
see the null hypothesis accepted or not. If it is accepted, in that case, there is no point in of comparison, ma'am. Right?
okay.
Yeah.
So अगर null hypothesis यहाँ पे accept हुआ, so means there is no significant difference between the population and the sample
Very
mean.
correct.
Hmm. But here both the 95% confidence interval, one is in positive and another is in negative. Means this is not reliable.
One is, yeah, that way you can say this.
So if it is not reliable, then we need to perform some another test.
Usually means it is not like we need to perform another test. Maybe there is some problem with the data or something, you can say. So it is, and one more thing, it is not always we need to report. This is what I'm saying. Many times people are asking to report. So you need to see
Okay.
whether you are reporting it or not. But I told you what is the interpretation of this. Getting me? Because I think collection of data is
Okay.
very
Okay.
task nowadays.
हाँ.
Yes. Okay. Now the next task for everyone. We are having the next variable also available with us, the name with name weight, I think, right? So suppose I need to check what is the weight given. Values are around 56, 52, 40 to 50 something, right? So suppose this is the data given to you, which is belonging to the students of suppose 10th class or from 9 to 10th class, right? So in that particular, what I can say, class duration, during that particular age group, I can say, suppose weight of the students, average weight is coming as 50. So now you need to comment the same.
Sorry, ma'am, come back again. What is the
I
task now?
said you need to assume now for me, suppose students are belonging to the age group of suppose 14 to 15 years, right? So in that age, suppose the average weight is suppose 50. So you need to now compare your sample mean from the 50 value.
Okay. And ma'am, for the previous assignment, I just did that comparison thing, analyze, compare means the 95% confidence is coming as negative for both.
Yes.
So, I mean, I think ma'am was mentioning it is coming positive and negative.
Okay.
95% confidence is coming as negative for both. Lower is minus 36.77 and upper is minus 26.1.
No, for me it is coming lower is minus 1.77 and upper is 8.82.
Ma'am, just check one thing. I was also trying to do it. In my compare one, it was showing as IQ because we had done the previous activity with IQ. So I changed it to the current one, which is the score. So score लगा के देखिए तो शायद चेंज आएगा. वो IQ वाला मेरे भी पहले आ गया था.
No, I didn't get what you said, sir. Will you please repeat?
So when I was doing that analysis, in my compare means it was already selecting on the right hand side IQ because the one previous activity we had done was IQ. So I had to remove IQ to the left box
you
and
need to reset. You need to reset firstly the box.
I did the resetting and then it has come as negative. So you
No,
may
I did that only. I reset that. I did that
For the
only.
same data, I don't think so, Sanjay ma'am. Two people are getting two different results. Is it possible for you to share your screen?
Just a second. Huh?
Yeah. Can you show the output window, ma'am? Or maybe you can perform again if you can. One is negative, one is positive.
So mean is right, 68.53. मेरा भी वही है 68.548. Standard is 2.671. 1.34. From one sample t-test, here the figures are changing. I am getting t-value of minus 12.029. Difference of 39. Two-tailed is 0.000. Mean difference is 0.31.475. And the lower one is minus 36.77 and upper is minus 26.18. So some figures are matching, some are not. Strange.
In my case, I think I'm getting exactly whatever the Sanjana ma'am is getting. Sanjana ma'am, I'll repeat my values. You please check, right? N is 40. I'm talking about the first table. N is 40. Mean is 68.53. Standard deviation is 16.548. Standard error of mean is 2.617. Is it correct?
Yeah, it is coming same here.
Same. Fine. Coming to the next table, one sample test table. T is coming as 1.347. Degrees of freedom is 39. Significant value is 0.186. Mean difference is 3.525. Then the 95% confidence interval for the difference, lower is minus 1.77, upper is 8.82.
Here my values are very different. So I will redo it and see.
Yeah. Sanjay ma'am, and what about your case? Have you got the same figure which I said?
Yes, same figure. Same figure.
Ma'am, I also got the same figure.
What I
You
said,
have
Jyoti
repeated.
ma'am?
Yes, ma'am.
Okay, fine. So in that case, Devasis sir, I think you need to check. We three got
Okay, I will do that.
the
Sure. I'll check it again.
yeah, no issues. What about the weight case? Have you people applied?
Yes, mean value is 47.8238.
Okay. And whether the hypothesis is accepted or rejected?
I think it is rejected because it is less than 0.05.
Fine. So in that case, you can comment now the sample mean and population mean thing. So I think sample mean is less than to the population mean, right?
Yes.
Okay, fine. Thank you so much, Jyoti ma'am.
Okay, ma'am.
Sanjita ma'am and Ashu Devasis sir, you please also check.
Yeah,
Yes,
checking.
ma'am. Same.
Yeah.
Yeah, it is 0 less than 0.05. So it is rejected.
Null hypothesis.
Ha.
Fine. That means we are concluding there is a difference. And if you will see the values, you can say the difference sample mean is less than to the population mean, right? Is it fine, everyone?
Yes, ma'am.
Okay, so I'll conclude my session on the note. Today we have understood the concept of parametric test. We have seen the concept of t-test, which is we are using for comparing the mean, right? Generally, we are comparing in case of, we have seen that there are two types of t-test, one sample and two sample. Today we discuss the one sample t-test. We have seen that we are comparing the population mean from the sample mean, and then we are deciding whether the sample is coming from the same population or not, right? So we have seen the theoretical aspect. We have seen how to formulate hypothesis. We have seen what is the formula which is we can use while performing the t-test manually. Then we have seen the formulation of hypothesis in the form of the what I can say symbolical form, or also in the text form or in the statement form. We have seen both, right? Then I explained you how we can use SPSS for performing the t-test, right? So I hope this session has given you a good level of understanding that what the t-test is all about and how we can perform one sample t-test using the SPSS. Tomorrow I'll talk about independent samples t-test, and I think although it is not written there in the what I can say the flyer or shared with all of you, but today I'll cover both the remaining t-test, right? That is the independent samples and the paired samples t-test, right? So that way this will be the end of the t-test, and after that we will discuss the remaining concepts according to the agenda of this FDP. I think this is all from my side for the day. Now platform is open for the questions and answers. If you are having any, you please can ask.
Ma'am, one question, like when we did the t-test for the IQ, you put a value of 100, but for the other two t-tests, we did not put any value. So that is okay, right?
Uh, I'm not getting. Will you please repeat?
When
What?
when we did the t-test for
Hmm.
IQ, we had put a value of 100.
So I
If you
think in
remember.
case of score, I told you 65. In case of weight, I told you 50. Test value, both the times I
Acha,
told you. I
acha,
think
acha.
that is the mistake you made. It is.
Yeah, I think so.
Yeah, that is why if you are not passing any test value, in that case, what the done by the SPSS, it will take test value as 0. So you
Correct.
can
Yeah,
see
I
your
think I did
output
not do.
is coming as
Hmm.
0.
Correct, correct. So
Yeah,
I did not do that. I did not.
yeah, that is the thing.
Okay.
So I think we have identified the error, right?
Yes, ma'am. Yes, yes. Okay. Also, the second part is that I'm sure in the remaining classes you will talk about the use of Z test also, because there will be
Z-
sample sizes.
I think so. When we talk about SPSS, usually SPSS generally talks about the t-test. The reason is what? When we're increasing the sample size from 30, so generally t-test is tending towards to the Z-test only. So generally it is t-test available in SPSS because I think we are generally collecting the data from more than 30 people, right? So it is based on the central limit theorem. When we are having the sample size greater than 30, or when we are increasing the sample size, generally data is tending towards to the normality, and that way the test is t-test is generally known as the Z-test.
Okay, thank you.
Yeah. Anything else?
No, ma'am. Can you share your PPT?
Slides?
For further theory reference, yeah.
Okay,
If
Yeah,
fine.
possible. If
it
possible,
will
yeah.
be helpful, ma'am, if you can share it in the group.
Because अभी समझ में आता है बाद में after a month it all goes.
Exactly. Exactly. वीडियोस और पीपीटी एक बार थोड़ा लिंक करके देख लेंगे तो क्लियर होगा.
Okay, fine.
Thank you.
Done. So I think this is all from my side for the day. No other questions from your side?
Thank you, ma'am. Good session, ma'am.
Yeah, thank you so much, sir.
Thank you, ma'am.
Thank you so much, Jyoti ma'am. Sanjana ma'am,
Thank you,
Devas
ma'am.
sir, thank you, Sunil sir, for making the
Thank you,
session
ma'am.
interactive. Thank you so much. So shall I call of the meeting. May I now call to
Yes.
the Yogi sir. Yogi sir, are you there? We are done for the day.
Bye bye, ma'am.
Yeah, thank you so much, sir. Bye, sir. Thank you so much, sir. Yeah, thank you, sir.